Okay, let's give you guys some practice. So here, show that this function here has only one and only one solution from minus infinity to positive infinity. Okay. Our normal routine is to sketch the graph, but this one's a bit hard to do. So let's just differentiate it and then analyze f prime. Okay. Yeah. So show that this here only has one solution from minus infinity to positive infinity. So press pause and have a go. Okay, so to do this here, if you differentiate it, so this is our original function here. Differentiate it. So rewrite this or reimagine it as cos of x to the power of 2. So when you differentiate it, this goes down to give you a 2 here, and then the bubble itself stays intact. And then you've got to times with the derivative of the bubble itself, which will be this. So basically, when you differentiate this, it will become this. Okay. Tidy this up, and then it will give you this. Now, if you look at this, what you've got here at the moment is one block times this block here times this block here. Let's just have a look at these two blocks, just so that we can try and understand what's going on here. So try and look at this block multiplying with this block here. So here you've got one block times another block. So imagine this dots here moving around here. So as it moves around, you've got the, remember, suppose it makes an angle of, let's say, x here. Then the height here is given by sine of x, and the across here is given by cos of x. But by the way, this is a circle radius 1. As it moves around, what you've got here is one thing times another thing. So what it means is you've got the height times the width here. So as it moves around, basically this thing here is saying get the height times the width as it moves around. So here you've got, well, when the dot is here, which is when x is 0, when the dot is here, the height here is 0, and then the across here is 1. So you've got 0 times 1, which will be, well, when you look at the product of the two, it will be 0. Let's say when it's here. Okay, so you've got the height here, which will be sine of x. So this is the height here, and then you've got to times it with the across, whatever that may be. But the point is that by the time the dot gets to around here, you've got the height. So when you try and plot a graph of this, 0, it would be 0. When it's at pi over 2, when it's at pi over 2 here, the height will be 1, and then you've got to times the width. The width will be 0. So 1 times it will be 0 here. Okay, and by the time it gets to around here, which will be pi, you've got the height of 0, and then times it with the width. So basically it would be 0 here, and by the time it gets around here, blah blah. Well, as it moves around here, you've got one thing times another thing, and as it turns out that the highest point is when it's at pi over 4 here. Pi over 4. This up and down here times this bit here, it will be at its highest point. Well, if you get a graph plotter and plot this, it will look like this. So this is a product of cos of x times sine of x. When it's at 90 degrees or pi over 2, it will be 0, 0, and 0. The point is that it would be less than 1. The highest point happens to be at 0.5. If you look at it as as pi over 4 here, if you get this times this here, for some strange reason it comes to 0.5. So the highest point here is at 0.5 here. Just bear in mind that this thing times this thing here is going to be it's going to range from negative 0.5 to positive 0.5. Okay, so looking at our derivative here, So this is going to range from minus 0.5 to positive 0.5. So when you times 2, when you times the whole thing by 2, it will look like this. Hang on. When you times that by 2, hang on. When you times this by 2, this point here will move up to here, and then this point here will move down to here, and well, when you times it by 2, it will look something like this. It will look something like this. Oops. It will go through here, and so on. When you times it by 2, you're going to increase the magnitude here. And then you add 2, and then your overall graph will look like this. Everything gets dragged up. The point here is that f prime. The point is that f prime of x here will always be above 0. Will always be above 0. Now, if f prime is always above 0, if f prime is always above 0, we know our graph is going to always be climbing. If we know that f prime is always greater than 0, then that would imply that the original function itself, f of x, will always be increasing. Okay, so all we need to do is find out an f of x where it's above 0, and then find out an f of x when it's below 0. So let's try an easy one. If you look at our function here, let's try 2 pi and minus 2 pi, because there's a cos here. So try something easy. So hang on. So at the moment we know that f prime is always greater than 0. So that would imply that f of x would always be climbing. Okay, would always be climbing. So we're going to try and choose a point when it's above 1, and try and choose a point when it's below. Sorry, we're going to try and choose a point above 0, and we're going to try and choose a point below 0. We're going to try 2 pi, and then here we're going to try minus 2 pi. If minus 2 pi doesn't work, then we're going to try, I don't know, 2000 pi, and then minus 2000 pi. The point that we're trying to achieve is that we're trying to get one positive and one negative. If we know that f of x is always climbing, it's going to cross only once. Okay, so let's try 2 pi and minus 2 pi. So looking at our original function here, f of 2 pi will give us this, which happens to be positive, because if you look at this here, this is very big in comparison to this and this. So the whole thing here will be positive. And then and when you try negative 2 pi, you've got negative 4 pi here. This thing is massive in comparison to this and this, so the overall thing will be a negative. Okay, so here you've got a positive, and here you've got a negative. And because we know the graph is always climbing, we know that when it's 2 pi, it's positive somewhere up here. When it's negative 2 pi, it's always negative. It's negative. So now that we know that the function is always climbing, therefore it only crosses once. We don't know where, but we know that it crosses once. Okay.